Good evening, and we're live again. Today, as you can see, I'm not alone. I'm with Tomass. Tomass is professional full stack developer, web developer, and Tomass currently works in an international company called Accenture. And Tomass is in Riga office of Accenture, and I'm really very glad to have Tomass today. As you may remember, Tomass last time made very interesting, compact, but very useful and interesting session on Git as a version control, I would say the most popular version control system. And today we have Tomass for the second part of this journey. And today Tomass will do a hands-on session on GitHub. So GitHub, I'll not tell you what is that, maybe you know, but Tomass will do that better than me, I think. Tomass, good evening.
Elkin, how are you?
Thank you. I am really fine. I was busy all the day. I know that you also was very busy. You had a lot of meetings, bunch of meetings in your job, and thank you for having time and joining us. So just a couple of things I want to tell you, everyone. Tomass, I'll just share my screen for a second. Here is the live stream chat. You can ask any questions to Tomass, okay? Anything during the session. You need to have some laptops, PCs, or Macs. Hello, Rainy Boy, to participate here. I mean, it's better to do with Tomass because then you will really learn something new, okay? Of course, you can watch it. We will have recording also. But here is the live stream chat. Hey, everyone. And cool. And I think let's not lose time and let's start immediately and right now. Tomass, the floor is yours, and we're all waiting for your session.
Can you stop sharing your screen and then I can
Sure.
start going? Okay, good. So last time we left off creating our kind of first project that's tracked by the version control Git, and we did it locally. So, we discussed the most basic concepts like branches, how to create commits, and basically how to manipulate our project locally. Project locally. I think I'm hearing some echo from you, Elkin.
Yeah, I'm not. That's interesting. I also. I'm not. That's interesting. I also. I'm not. That's interesting. I also. I'm not. Okay, let me check. Okay, let me check.
Yeah, so for now, I guess you can just. Yeah, good. So today we will kind of take one step further and learn about remote repositories. GitHub is just one example of a remote repository that you can have. We have other ones such as GitLabs. Then we could have something like Bitbucket. These are probably the most popular ones besides GitHub, but there's many other ones. Which one you use, many times it will not make much of a difference to you. It generally just tends to be some individual features that tend to differ between these kind of cloud service providers. But in our case, we're going to work with GitHub because it's probably the most popular one. And hopefully you have an account on GitHub. If you don't have, then you should just go ahead and sign up. It is pretty fast, so it shouldn't take you too much time. In my case, I already have an account, so I will go ahead and sign in. I'm going to go a little bit off screen. I'm going to get in my credentials. And here I am on my kind of homepage when I have logged in. So the first thing we will do is we will create a new remote repository. So we will go over to repositories and just go and click new. So we have several options that we can select. The most, I guess, important ones in your case is, I guess, the owner, right? In that case, it's just going to be me, your repository name. I'm going to go ahead and write custom clock, since that is the name of our project. You can add in a description if you want. As you can see, this is optional. I'm going to go ahead and skip that. And the other important option that you have to pick is either you're going to make a public or a private repository. So the difference between public and private is basically who can view it and then basically also clone it, right? So if it's public, then anybody can view it, anybody can get your code. If it is private, then only you and the people you choose. So I'm going to go ahead and pick public because this isn't something that, this isn't a private project. This is something I want everyone to have access to. And then you have some options here. In this case, we'll just ignore them because we already have a repository. So we'll just create a completely empty one. So let's go ahead, press create repository. And that is it. That is it. And you have created a remote repository. The next step is we actually have to get code into this repository. So you can see that we have some instructions already written for us here. I'm going to try to simplify. I mean, this is already really simple, but I'm going to go ahead and do it step by step myself. So the first thing, you have to go over to your command prompts or Git Bash, or if you're using PowerShell, whatever terminal you're using, you have to navigate over to it. Hopefully you remember how you can navigate over to the folder. So you should be located inside your folder. In my case, it's custom clock. And just to make sure, you can always just write git status. And you can see, yeah, we're in the branch master. We have some files that are tracked, but basically we make sure that, yeah, we're in the correct folder and we have git initialized here. And so all of this is what we did last time. And I'm just kind of picking up from there.
Tomass?
Yes.
Here is one question in Discord channel. What is the biggest difference or largest difference between GitHub and Bitbucket, if you have experience with Bitbucket?
I mean, I'm probably not going to tell you on the spot what is the biggest difference. But like I said, it's always just a matter of, there's a lot of comparisons that you can do online. So I can just go ahead and go into GitHub versus Bitbucket.
Oh, okay.
And then
this can be done.
list you some differences. On the top of my head, I am not that familiar with Bitbucket, so I cannot tell you what features specifically it has or doesn't have. But yeah, otherwise, if you want to find that out, it's really easy to always just go online, GitHub versus Bitbucket.
Okay. Cool. I can add that I'm from myself that maybe the biggest difference that GitHub was bought by Microsoft.
I mean, if that is important in your decision making, then I guess sure. In that case, I guess the biggest difference, GitHub is more popular. I guess that would be a very big difference as well.
And it was also more popular before the acquisition. So yeah. But for that, just compare that in the internet. Thank you, Tomass.
Okay, so let's just get back to where we were, okay? So we have our local folder, right? So this is our local Git, or we also have it right here in our Windows Explorer. And then we have our remote repository here. So what we want to do now is connect these both together so that we can make changes locally, and then we can push them over to the remote repository. And then the remote repository would have all the changes we have committed locally. The same we will be able to do in reverse. So if there's some changes in the remote repository, let's say by other people, then we can also really quickly pull them into our local repository, right? So the idea is that right now we want to connect this remote repository that we have on GitHub with our local one that we have on our computer. So in order to do that, first of all, you have to grab this link. You're going to have this link written on your kind of main page for your repository. You have to copy it. Let's go back to our terminal, and we will now write git remote add origin, and then we paste in this link we copied. And so we basically have to take this link, put it here, but before that, make sure to write down these commands. So if I try to translate it in English, it basically means we're adding in a remote repository to our local Git version control. And this is kind of the location of our remote repository. Let's go ahead and press enter. And if we write git remote -v, make sure that you have this kind of appear so that you can really know that we successfully added in this remote repository. I think a very useful note is the word origin. That is typically the word that we use whenever we refer to remote repository, right? So if you see origin in your Git workflow, just think that's your remote repository, right? This is your origin. Good. So now we have added the remote repository to our local project. Now what we want to do is we want to take our code that we now have locally, all these files, and we want to push them, or I guess a similar word for push would be upload, right? So when you hear push in Git, think basically upload. Right, so that kind of means you're uploading these files to your remote repository. So let's go ahead and do git push -u origin master. So obviously the first command, we're working with git. So we go git push is basically upload. So then now we're saying we want to push this code to this repository. -u stands for upstream. That basically kind of means, well, upstream means that kind of towards the remote repository. Origin is basically, as I said, you're saying that you want to push to this remote repository, and master is the branch that you're pushing. And so if you were using a different branch, like in our case, we had the branch cat, then we would do cat. If you have a branch named ABC, then you would do this, you replace master with ABC. So let's press enter. And you can see that we have successfully pushed the changes here. And now this master branch that we have locally is tracking the same branch that we have here. So let's refresh and check if it worked. As you can see, it did. Now your online repository that you have on your GitHub contains all of the files that we had locally, or basically all of the files that we have committed locally. So for example, if we go to images, you can see that we have cat, jungle, mountain, savanna. But if you go to our local, we'd have 2 additional images that didn't appear. And the reason they didn't is because, as you can see previously, they are not tracked. Right? So from the previous lesson, files have to be tracked, otherwise Git will ignore them. Right, so now let's quickly look around, see what we can see here. So the two most important things is we have our branches. So you can see this button drop-down box here shows us the list of all our branches. And then we have our commits. And so if we go back here, we have all the commits that we have made. So if we click here, we currently only have master branch. And if we go to commits, then you can see that we have the two commits we made in the previous session. We had the first version and then we have the new cat design. Now you may have noticed that even though locally, so if we write git branch, this shows us all the branches we have, master and cat. The cat isn't pushed. And the reason is because we didn't specify cat, we only specified that we want to push master. If you wanted to push all branches, we can do the command git push all origin. So now if you had other branches that would also be pushed, this is generally not a command you will use a lot because you technically shouldn't, but I guess in our case, since we're pushing our first kind of version to remote, I guess we can do that this once. So now you can see in the branches, and previously we only had master, now we also have cat, and we can go ahead and switch between them. And so now we're on the cat branch, now we're on the master branch. And similar to how we could do in Git, where we could kind of go back in time, we could check previous commits, we can also do the same in our GitHub. If we click on commits, we can press on our first version. Here it's going to see all of the changes that were done, or we can click here, which will say browse to repository at this point in the history. And now we will see the way how our code looked when it was when we created our first commit. So probably you can now see that we don't have the cat image. If you go to props, they will also be kind of different from what we have them now. And now we can just go back to the original one, to the latest one. Hey, good. So that is basically kind of how we can set up a remote repository. We do git remote adds, then we push up the changes, and now everything is remotely tracked. Let's try create a new branch. So let's go ahead and do git checkout -b mountain. This will create a new branch locally called mountain. So if we refresh, it's not going to be present yet because we haven't actually pushed it. Now remember, whenever you do changes locally, they're not going to be reflected on your remote branch until you push them. So in order to do that, let's do the same what we did previously with the master branch. Let's do git push -u origin and mountain. You can see it, we create a new branch, we refresh, and now instead of 2 branches, we now have 3. Right, so the basic workflow, how you kind of do things is first you do changes locally. So we would do something locally. Then we need to use the command git push. So let me write that down. Sometimes you may have arguments. So in our case, we had them. Right? So sometimes you might have arguments. And only then things will appear on your remote branch. Right? So this is our remote repository. And let's try making some changes locally, creating a commit, and then adding those changes to this remote repository. So I'm going to go over and open up this file. Hopefully you remember how it can be done. So if I go here, all right, so you can go ahead and open props in any text editor. It can be a code editor. In my case, I just open it with Notepad. Now let's make some changes. Okay, so let's change the image to mountain. Let's do brightness a little bit higher. Color, I'm going to do burly wood. Let's increase the size to 150. And just make it alpha J and save it. Let's save it. So hopefully it looks, yeah, it looks something like this right now. So let's now take these changes and push them to our remote repository. So let's go over here. If you do git status, we're going to see that, okay, we have modified props. Now let's go ahead and add that. Git add props.js. So first we need to track it. Then let's make a commit. And let's name it change style to a mountain block. All right, so now this are the two steps that we learned in the previous session. And now let's do the kind of next command that we learned just now, which is git push. This time we do not need to use these arguments because we're not actually creating a new branch. We already are tracking it. So we can just go ahead and press git push. And it should, yeah, so you can see that automatically kind of updated in real time. So if you go over to mountain, now you have 3 commits. We had our latest commit here, right? So these were the first 2 commits that all branches have, and this is our latest one. If you click on it, you can see the changes that were done. So red is what has been removed, green is what has been added. So this makes it really easy in case if someone else makes some changes and you want to know what was changed, you just go to that commit, you press it, and now you have a very convenient way how to compare, okay, what did my teammate actually do? So this is how we do changes locally, and now we push them remote. So let's go ahead and try to do something else, right? So one of the benefits that a remote repository has is that it basically means that your project cannot really be lost anymore. Because, for example, if your computer breaks or for some reason you lose your files. So because I've now have my code on remote, I feel very confident to just going to my desktop, this is the folder, and deleting it. Okay, so apparently I can't delete it because something's opening it. Yeah, so I'm not exactly sure what is currently using it. Oh, probably this. All right, let's just ignore that. Let's go ahead and ignore it, and let's imagine that we have deleted it and we have messed it up somehow, and now we want to get a new version. So I'm just going to go ahead and go here. I'm going to create a new folder. Let's do new. Go here. I'm going to open Git Bash, or I can go to command prompt. Let me quickly navigate to the location. So desktop, new. And now let's say I want to recover something that I've lost. So I can easily do that with something that's called Git Clone. So again, I have to go to my remote repository. I have this dropdown called code. Click it, copy this. Let's go to my command prompt and do Git Clone and paste in the link that I copied from here. Just be able to press enter, cloning it to custom clone, and it is done. So if I go back to menu, you can see that I have cloned it. So it doesn't matter if this version here is broken or I lose it or it deletes or something happens with it. Because we have now pushed our code to remote repository, we can safely recover it from basically any computer that has access to internet. So now I can go here. I can open up props and continue coding or making changes as I wish. Because I have basically covered everything that I might have lost. Right, so that's Git Clone. Right, so that is one benefit of having a remote repository, is that we are now kind of safe from any mishaps that might happen locally on our computer. The other benefit that this has is in collaboration, right? It makes it really easy for several people to work on one code at the same time. And that is done with something called pull requests. So let's just say that we have this master branch. And if you remember from last session, this is usually the main branch where all approved changes are, right? So this is the main branch where all the approved changes are. And then you're, say, some new developer, and you create this new mountain branch, and you make some updates, right? So a developer makes updates. And he does it on his own branch, so he doesn't, he doesn't bother or impact the work of other developers. He does it on his own branch. Now he says, okay, my changes are done. I like the design of my new clock. And now I want to take those changes and I want to give them to everyone else, which basically means I want to merge them to the master branch. For this, we will use something called a pull request. Right, so we have this button here that makes it pretty convenient. Or we can just go over to this tab here. Pull request. And now we want to make a new pull request. So let's click here. And you have two options. You have the base and you have the compare. The difference is basically this is the branch where you're merging into. And this is the branch with the new changes, right? So this is the branch with the new changes. So if you look at our situation, base master, because that's the main branch where we're going to put in our changes. But the new one is mountain, right? So we have our updates in mountain. So we click here. Here it gives us a quick summary. Let's just go ahead and create the pull request. Right, so we select base as master because that's where we're going to put the changes into, and mountain is the one where we're going to take the changes from. So we go ahead, create pull request. Here we can give some kind of a name. So for example, I'm just going to go ahead and write mountain clock design. You can add some comments if you want, and then you can create pull requests. Right? There's some other options as well. Those are kind of, they're not advanced, but for this specific session, they're not really that important. So let's go ahead and create a pull request. Right. So what does this mean? This branch has no conflicts with base branch. That basically means that there's no merge conflicts. So we kind of touched upon them at the end of last session. Merge conflicts is when two developers make the change at the same place, and they both want to merge to that place. Then your Git is going to say, okay, so which one should I take? In our case, we don't have that, so there's no merge conflicts. We simply have this pull request. Right, so now there's several things we can do with it. Let's say you're not a developer, you look at this, you can go to files changed. This will give you a summary of all the changes, so you can see that, okay, I like this, okay, good. Or you're gonna say, okay, I actually don't like this. How about we use a different mountain image? So you can add in a comment, right? So we start a view, and then we can look at this and say, text is too large, make it smaller, right? So you can add in another comment.
Tomass, sorry for interrupting you. Can I interrupt you? There's a question from Zeta. How to duplicate a branch?
What exactly do you mean by duplicate a branch? Do you mean just create another copy of a branch?
I think most probably, yes.
So that can just be done by creating a new branch. So I'm going to just go ahead and click finish your review, submit review. Let's get back to this later, but okay, so let's say here's our command prompt, and let's say we want to duplicate our mountain branch. What we will do is let's quickly navigate into custom clock, Git status. Okay, so we're currently on branch master. So let's go over to git checkout mountain, and we want to duplicate this branch. So we would just go ahead and create a new branch from this branch. So we would navigate to this branch that we want to duplicate, and then write git checkout -b, which creates a new branch, and then write the name. So I'm going to do mountain -duplicate. Okay, so now we have a new branch that is a copy of the previous branch that we had. Right, so hopefully that answers your question. This is how we duplicate branches, right? So a quick summary, checkout to the branch we want to duplicate. That is step 1. And then step 2 is git checkout the name of branch. And now you will have duplicated your branch, right? So it's very easy. Hopefully that answered your question.
Thank you, Tomass.
Okay, so back to reviews. Right? So this is a pull request. We have just made a pull request. We have added in some reviews, right? So let's send in the developer and thinks, okay, I don't like this image. Let's use a new one. Or the text is too large. Let's make it smaller. And then, you can engage in a conversation. For example, you can fix it and you say fixed. Resolve conversations is basically means, okay, this is resolved. Then you have commits, which is the summary of all the commits in this pull request. And kind of that's basically most of what you'll be doing whenever you work with pull requests. And then finally, when all of this is done, and let's say you get approvals, other developers saying, yes, we like this, let's put these changes into our main branch, then we would just go ahead and click merge pull request. This is a commit name, so we're just kind of making a new commit. I'm just going to go ahead and write add mountain changes to master, confirm merge. And it says pull request successfully merged and closed. And it also gives us the option to delete the branch, because now that since all of these new changes are the master branch, we don't really need the old branch. I'm not going to do it in this case, but oftentimes that's probably what you will be doing. So we go to codes, go to master, and as you can see, the master now we have the changes we did in the mountain branch, and we also have a new commit, which is basically the merge commit, right? This is the commit that was made when both changes were put, when the master branch was merged or put together with your mountain changes. So that's how pull requests work. Now, this is basically your entire workflow when you will be working in a real project most of the time, right? This is going to be most of what you'll be doing. There's going to be some other stuff, and we're going to touch upon those. But now I just kind of want to summarize what we kind of have done up until now, just to give a better, clearer picture. Let me just quickly draw kind of a blackboard here. So this is going to be your typical workflow. Or flow. So first, first of all, you're probably going to be creating a new branch. So you'll create a new branch for your changes. So you're going to have some branch name, I'm going to go ahead and write the git command for it. So git check out the new branch, or I don't know, branch new changes, something like this. Right, this is going to be your first step that you'll do. I'll minimize this so it's more visible. Then the second step is you're going to actually do the changes. Let me color code this in yellow because this is an actual Git. So you actually do, so make changes in your code, files, or whatever else you're making changes in. Then afterwards, you will make a commit, right? So for that, you will have to make a new commit, which usually is going to consist of git add -a, which just means you're tracking all the files that you made changes to, then git commit my new changes. Yeah, so this is kind of what we did in the first session. Let me quickly summarize this in one. And then today we learned about the next steps, which is actually we need to get the code to this remote repository and then merge into the master branch, right? So those would be the next steps. We have step 4. So we push changes. Origin changes. Or in other cases, you would just have git push if it's not a new branch. So let's say you already have this branch. You're just pushing new changes to it. And then once those changes are pushed and you have, all of the changes are done, and okay, now I want to put them in the master branch, you'll finally create a pull request. Create a pull request. Get a review. And then finally merge. And so this is part 2, or this is, current session. So current. Right, so this is basically a quick summary of a typical workflow that you will be doing as a developer in a real project. For a new branch, you make changes, you make a commit, then you push those changes or the commits onto the remote repository, and then finally you create a pull request, get reviews, and then finally get it merged. This is most of the work you'll be doing. And if you know this, you are probably already ready. Well, I guess assuming you know how to do this part, right? So I'm assuming you know how to code. You're probably ready to actually join a team and start working, collaborating with them. Yeah, so I hope that's clear. This was usually the part where I wanted to take more questions, but I guess I answered some of them already. So I'm just going to go ahead and address some other typical things that you might be doing on Git repository. All right. So another typical thing might be issues. Issues is basically, you can think of it as your to-do list, right? So whenever someone wants to make some update to your code, wants to fix a bug, or basically any time there's something you want to do with your project, you will most likely create a new issue, or it can be a ticket, right? Depending on what kind of software you're working with. If you're working with something like Trello, then it's probably going to be like a new note or board. If you're working with Jira, it's going to be a new ticket. In GitHub, they call them issues. So let's go ahead and create a new issue in GitHub. So click new issue. This is the title of the issue. So for example, let's say create, let's say add images for cities, right? So let's say you want to create a new issue, like, hey, let's add in some images in this project for some cities. And then in comment, you can say, you can specify, we need images for Riga, Berlin, London. Yeah, and then you would just do submit new issue. You can do assignees. So this is typically who does the work. So let's say I'm going to do the work. I'm going to collect myself. Labels is what kind of change you have. These things can be very different depending on a project. You have some default ones. In some projects, it's probably going to be some version number, or etc. But yeah, that's kind of what you can do. And now let's do submit new issue. All right, so now we have a new issue. So if another developer comes along, he clicks on this tab, he's going to see, oh, okay, so we have some to do that needs doing. So you can click on it. He reads the description. He's like, okay, we need something more. Okay, like also add Stockholm. Right, so you can have a discussion here in comments about this issue. Then someone else can do what we did previously. They can create a new branch for this issue. They can do the changes. They can do the pull requests. And if it's reviewed and merged, then finally what you would do is you would close this issue. And what closing issue means is basically you're marking it as either done or in other cases rejected, right? So sometimes you might have this issue and then after the discussion you think, okay, actually we don't need it. Then you can reject it. Or you can, do it and then mark it as done and then you just close it. Now it's closed, we go to issues, and you can see no open issues, but we have one finished. So that's basically issues. This is your to-do list. Kind of, right? This is one way how to think about it. Right, so let's try something else. Something that, in my opinion, is a pretty good feature that GitHub has, and that's called GitHub Pages, which kind of allows you to make your project kind of linked to like a web page almost. This can only be done on public repositories. So in my case, it is a public repository, so you can do that. So let's try doing it quickly together. Hopefully, if you're following along, hopefully your repository is a public one as well. Or if it's not, then you can go to settings and you can probably make it public. Obviously, only do this if you don't mind other people seeing your code. If you do, then you shouldn't do that. Right? So then we can go over to pages. And this is going to be really easy. We go to pages, we have the source, and now we just select the branch that we want to make as the kind of the source, right? The one that we want to display, because we have different versions. Let's go ahead and pick master and click save. So now it says your site is ready to be published at, and then it gives you the link, which is going to probably be your username, GitHub.io, and then here's going to be your repository name. You can click it. It's not going to be available for a few seconds. Like I said, it normally should just be only a few seconds. So if you just wait a little while, then it should eventually appear. But like again, my reminder, this can only be done with public repositories. You cannot do it with private ones. As this can be pretty useful. Typically, it can be useful either if you're making some open source project that you don't mind people seeing the source code for, or maybe you're creating some project that you want to display maybe to your future employer, right? Some personal project, so you can like easily give a link to your interviewer or recruiter, and then they can see what you have done. And you don't need to kind of bother yourself with other cloud services that will host your web. Let me see if I can refresh. As you can see, here it is, public. Any one of you right now that are watching this live stream can now go to this link. I'm even going to go ahead and put it in Discord. And you can now access this clock, right? You can see it. You can also go to my repository URL, and here you can see all the code that I have. Right, so all of this is public, and you can now go ahead and play around yourself. Last thing, let's talk about README. This is something that also very typically most projects have. This is kind of your quick overview or description of your project. So an example, I'm going to go ahead to Angular GitHub because they have a really pretty one. So let's say you open up the repository for Angular. As you can see, there's a lot of files, probably very confusing, gonna take a while to understand. But for that, you have README, right? So this file kind of gives you a quick overview of how to work with it, how to use it. It gives you some links to more materials. You know, you have some credits, contributions, etc. Basically, it's just like a quick overview of what your project is about, how to quickly use it, or a quick overview, maybe some credits, license, etc. So we can go ahead and do that now ourselves. This is pretty easy. We just have to click the add a README button, or we can also do it manually by creating a file called readme.d. Let's not bother with that. I mean, if you have this button, we'll just go ahead and click it. Here you can edit the file. There's many different styling options. The most basic ones is titles. So this hashtag custom clock will basically make it look like a title. It's going to be a pretty large text. We can go ahead and do this, which will make another title, but a little bit smaller one. So you're going to see it. I'm going to go ahead and create a description. This is a customizable clock. And then here you can create another title, instructions. Let's go ahead. Go to props.js and change values. Change values, right? And then maybe I can do even a smaller title. So now we have 3 hashtags, and we can do, let's say, variable meanings. Or just let's do variables. And then here we can say back. Let me put this next. So we have background. Changes image for the background. Brightness. Background brightness. Then we have color. Color of the text. Then we have size. Size of the text. And then finally we have alpha, right? So who made the clock? This is another commit. So you have to create a new commit to add this file. I'm going to write add readme file. I can commit it directly to master branch as a commit new file. And now I have a really quick description of what my project is and instructions how I can use it, right? As you can see, this is the largest title. This is the smallest one because here we had 2 hashtags. And then here, this variables is the smallest one because there are 3. And you can keep on adding as many as you want. And the more you add, the less significant the title is going to look. But yeah, that was basically it as a quick introduction with how to work with remote repositories, and specifically the main features that you will be using when working with a GitHub. From my side, this is kind of it. So if you have any questions, you can go ahead and post them in Discord. Otherwise, maybe we can welcome back Elchin and see if he has something to say. I've noticed that he's been popping in every once in a while as I was presenting. Elchin, are you here? Okay, I guess he's gone for a while now. Like I said, from my side, this is basically it. We're gonna have to wait for him because he's the one that actually closes the stream. Yeah, so let's just start pinging him and getting his attention. Since he is the moderator of this stream. Any questions, right? So this is a really good time when you can ask questions in Discord. Right, so if you go over to Datorium, live stream chat, As you can see, I'm trying desperately to get his attention, and you can help me out by asking me questions. What about GitHub Actions? Okay, so GitHub Actions is kind of like your add-ons in a way, right? So this helps you enhance your workflow with different add-ons, right? So something that might be pretty useful as you become more, as you create more professional projects would be something that's called, let's see, well, build, test, deploy your code, right? So this is something that in short can be called a pipeline. Right, so pipeline is typically something that you build your code, you test it. So typically you should have automated tests. They automatically, you have kind of like a bot in a way, or some script that does something to your project and then checks if your project reacts in the correct way. And then if it does, then it deploys it to some environment, right? So that environment would be, so most typically that would be your production environment, right? That would be wherever you're hosting your project or website or whatever else you're making. You can go ahead and you have some kind of add-ons here that might help you with that. OpenShift is like a very useful service that lets you host your applications in the cloud. This is something I'm familiar with. Yep, Node.js is for Node projects for deploying and testing them, right? So this is kind of like your add-ons that it will improve your GitHub flow. What are some unwritten rules when working with Git and GitHub? Okay, let's see. Some unwritten rules. Okay, so I'm not sure if they're unwritten. Usually you're gonna have a lot of people talking about them very strictly. But first of all, commit messages are important. Okay, I think this is something that just kind of comes from experiences, because when you're gonna look back on your commits, you're gonna have hundreds of them piling up. And the last thing you want to do is you want to see commit messages that says change, update, new version, new, right? You want to see commit messages that are actually meaningful, right? So in our case, you would say added the new files or change the text size or added the readme file, right? So something that you should really be conscious of when you're making new commits is please do make them meaningful, since that makes it a lot easier for other developers when they want to track down the history and see what has happened. That might be an unwritten rule. Like I said, you can still do it, but if you're going to make like very random commit messages, it might affect you badly in the long run. That is like, I guess, one rule that you could follow. Another one could be regarding branches, right? So as I said previously, master branch is typically going to be the branch where you only merge changes that have been approved, right? So you should almost never push new changes to the master branch. Always create a new branch and then do your changes in the new branch. And then once those changes are done, create a pull request to your master branch, right? So unless there's some specific situation in your project that allows it, you should almost never put your changes directly to the master branch. They should always come through a pull request where they're approved. As that could be another one. Yeah. I mean, there's other ones as well, but they're usually cover more complicated topics like Git rebasing and stuff like that, which is, not really covered within this time frame. Also, this session reminded me of this meme. Okay, let's look at some memes. I like memes. Okay. Yeah, so obviously when it comes to branches, do be careful when you're creating new branches from the existing branch. Try to keep it as simple as possible. You have one master branch, and then you just make new branches from this master branch, right? So if you make new changes, make them from the master branch. Try to avoid doing something like this. Doesn't mean you cannot do it, right? There are definitely situations where this could be a viable option. Like I said, if you start doing this, you're going to start getting something like this. And now it just looks like a metro line, right? So you don't want your Git history looking like it's a map for metro. All right, so let's see if Elchin maybe is back yet. Let's ping him some more. Let's see if I can message him directly. Hi, Elchin, come back. Let's see. Any other questions they might want to ask? All right, so let's see. Maybe let's try doing some other stuff until he comes back. Let's see. What could we else do in our repository? I guess we can just try doing another branch, right? So let's say we have, yeah, so we have cat here, which is the previous one. And we have the master branch, which is the latest one, and then we have mountain, right? So these are outdated branches. So this is how our master looks like now. So let's say we create a new branch locally. So let's go to git checkout master. Let's create a new branch from master. Let's call it Savannah. Oh, I misspelled it. That's fine. And then here, let's just do quick changes. Let's change it to Savannah. Let's increase the brightness. Let's do the color white. Let's make the size a lot bigger. And then offer anonymous. I don't know, camel. Let's do camel since it's. Actually, wait. Let's just do anonymous. I forgot. Is it a desert or is it an savannah? All right, so it's a savannah. So let's do an elephant. Really not important. Let's just do that. Git add a, git commit design with an elephant. Let's do git push, view origin, this. Right, so because we're creating a new branch, we should add in this. Let's refresh. Right, so if you see now, this master clock, we have the old version. Let's create a quick pull request. Checks for merging. Oh, perfect. There's a branch. This branch has conflicts that must be resolved, right? So I can now go to resolve conflicts. And now I basically have to select which one to pick, right? So this is actually perfect, right? This is a merge conflict. So you can see these things were affected by two developers at the same time. Well, there's one developer in my case, but like two branches affect this at the same time. So now you kind of have to choose which one you want to make. So in our case, we want to take the Savannah one. So we take here, and mark as resolved. Commit merge. Now we have resolved the merge request. Let's do pull, confirm, merge, and closed. I'm going to delete the branch because we don't need it anymore. Let's go to code. Okay, so now our master branch should have the latest commits. And after a few seconds, this clock should update. Right, so it takes a while. Now it's the old one. In the meantime, do you have any Git horror stories like this one, maybe? Thankfully, no. In my experience, I haven't really had any Git horror stories. Thankfully, everybody I've worked with has been very clean with their approach into how to do Git, Git workflows. The only horror stories I can tell you are horror stories from before I used Git, because back then I didn't know how to use. I didn't really know how to use Git, so I would do something like this. I'd have like this old version, and then I create a new one, and this would be like custom clock, and then I add in new. And then afterwards, I would do some changes here, and I realized, wait a minute, I need some new ones, and I would have custom clock, new. Right, so this is, I guess, a horror story from before I knew how to use Git, and I was first just starting out as a developer. And this was my version control, right? So I had 10 different folders, and basically I had new, final, real final. This is final for real. I guess that's the best horror story I can tell you, but I guess it's not with Git, it's just with me not knowing version control. Okay, so I guess it's 10 past. This is, I guess, where we're going to finally end. When Elchin's going to come back, he's going to close the session. But for now, thank you all for attending, and I hope these 2 sessions really helped you learn Git. Okay, so bye, and I'll see you guys in a future stream maybe. All right, so see you all.
Okay. All right. Tomass left. Thank you, Tomass, for this.
Hey, you're back. You disappeared. Where were you?
I had a call. Yeah, I know that we're live, but I have very important call, and I was talking there parallelly.
I was getting a little bit desperate, and I started to ping you. I cannot really end the stream.
No, everything. I'm here. I'm always here. We were talking about which framework to use, which is better for REST API and not, and so on. So it was really very important. Tomass, thank you very much for this session. And we know that you are always in our community, and we really appreciate that. Tomass, by the way, is the master of our WebTech course. And this is the course for beginners in the web technology like HTML, CSS, and JavaScript. We are planning more courses, so stay tuned. We will have more streams, more interesting topics. Tomass, one more time, thank you very much. And
it was a pleasure. See you.
Thanks. Bye-bye, everyone. Bye.